Section 1.6, Subtracting Integers. In this section, we want to model subtracting integers using tiles, and we also want to subtract integers using rules. But let's begin with modeling. As in the previous section, I have a yellow block, which represents one positive unit, and I have a red block, which represents one negative unit. And what we can do in tiles is pair a yellow block and a red block together, which really represents a positive 1 plus a negative 1, which is 0. Therefore, this is called a zero pair. And this will be used when we actually model subtracting integers. So let's proceed. Here, what I want to do is write a number sentence for each model. So in this situation, what I have is really a positive 2 plus a negative 6. And I use a zero pair here because the yellow and the red cancel out. Positive 1, negative 1, they cancel out, and they cancel out here. And that leaves me with a solution of a negative 4. Another way I could actually write this is 2 minus 4. Therefore, instead of 2 plus a negative 6, I can go 2 minus 6 and still achieve a negative 4 as a solution. On my next problem, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a negative 10 blocks. And I'm going to subtract out a negative 5 blocks. And now notice, I have a total of a negative 10 blocks. And in that situation, I can actually subtract out a negative 5 blocks because I have that many blocks to take away. And when I take away a negative 5 blocks from a negative 10 blocks, I'm left with a negative 5 blocks. Another way of saying this is a negative 10 plus 5. We have to use tiles to help you find each difference. Here what I'm given is a negative 5 minus a negative 4. I'm going to bring over a negative 5 tiles. And here's my negative 5 tiles. And within this number, I can actually take out a negative 4 tiles. And when I take away a negative 4 tiles, that's going to leave me with one negative tile. Therefore, a solution, a negative 5 minus a negative 4, leaves me a negative 1. Next, I want to use tiles to help find each difference. In this problem, I have a positive 5 minus a negative 3. I'm going to bring over 5 blocks. But notice in this problem, I have 1, 2, 3, 4, 5 blocks. But I don't have any negative 3 blocks to take away. I need to bring over 3 negative blocks. But when I bring over 3 negative blocks, I need to associate that with 3 positive blocks because I want to add 0 pairs. Adding 0 pairs doesn't change this part of the problem. I'm going to add in 3 negative blocks. Therefore, I'm going to add in 3 positive blocks to offset those 3 negative blocks. Now, what I do is I have 3 negative blocks in my problem. I want to take those away. And once I take those away, I'm left with 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 5 minus a negative 3, my solution is 8. My next problem, I have 2 minus 3. Positive 2 minus 3 blocks. And what I need to do is I don't have 3 positive blocks to take away from here. I need to get 3 blocks. So if I bring in 3 yellow blocks to take away from these 2 blocks, I need to offset that with my red blocks. Now what I want to do is take away my 3 yellow blocks, or 3 units. When I pull that away, I now can create zero pairs. Here's my zero pair, which cancels, my zero pair, which cancels, and what's left is a negative 1. 2 minus 3 is a negative 1. In my next problem, I'm going to have a negative 2, and I want to subtract 3 positive units. I don't have 3 units, but if I bring in 3 units, I need to bring in 3 zero pairs. And now what I do is I'm going to pull 3 positive units out. And now I have my solution, which is left 1, 2, 3, 4, 5. Negative 5. My solution is a negative 5. Now, if I go back and take a look at this, this really can be written as, in my addition rules, as a negative 2 plus a negative 3. Notice each give me a negative 5. Here, I can write this as 2 plus a negative 3. And notice if I use these rules, different sign subtract, use the sign of the larger, I get that solution. If I go here, a negative 2 plus a negative 3, same sign combined, I get that solution. And the previous one, this basically turns into a positive. What I'm doing is adding the opposite of what's here. So 5 plus 3. Subtracting a negative gives me 5 plus 3. 5 plus 3 is 8. 5 minus a negative 3 is 8. And here I have a negative 5. Again, subtracting a negative gives me a negative 1. Now that we've looked at subtracting by modeling, we want to look at subtracting integers by using the rules. So the first one, we want to copy the problem from the book. That's a rule that we always go by on any of our pre-algebra problems. Number 2, I want to apply the rules of adding and subtracting 2 numbers at a time, then proceed if needed. In other words, I'm still going to use just 2 numbers. So the first rule for subtracting integers, this is our arithmetic definition. If I have 3 minus 7, I want to rewrite this expression as 3 plus a negative 7. In other words, I want to view this problem as a 3 and a negative 7. The algebra rule is this. If I have a minus b, or in other words, any number, it could be any real number, fraction, decimal, integer, minus another fraction, decimal, integer, equals a plus a negative b. So if I just have a minus sign, I can change to a plus and make that a negative b. This form is the adding a negative number. Change minus to plus and make the second number negative. Our next rule is this. If I have a double negative in my problem, in other words, I have a negative, negative, whether there's parentheses there or not, that would be known as a double negative. I want to change that double negative and make it a plus sign. And here's our algebraic expression for that. A minus a negative b equals a plus b. A double negative changes to a positive or plus sign. Once I have applied these rules, in this situation, once I've applied these rules, what I'm going to do is apply the rules for addition. So let's proceed and look at some examples. What I would do now is make sure I copy these rules down so you have them with you as you go through the problems on my examples and on your assignment. Let's take a look at some examples. My first rule is this. I want to copy the problem down from the book. The next thing I always want to look at is this. If I'm not multiplying or dividing, I'm always adding. If I'm not multiplying numbers and variables together, or if I'm not dividing numbers and variables together, I'm always adding based on the rules of addition, whether I change the look of this problem or keep it the same. Number 1, I'm going to copy this problem from the book. I bring down the negative 31. This is a double negative. I change that to a plus sign. Now, I'm not multiplying or dividing. I am adding or subtracting. In other words, I'm always adding in a sense because I'm going to determine this is a negative, this is a positive, different sign, subtract. That gives me 6. 31 minus 25 is 6. Use the sign of a larger. 31 is bigger than 25. That's a negative 6. Number 2, I bring down my negative 12. I change my double negative to a plus 5. I can keep that in parentheses if you wish. It doesn't matter. I can take the parentheses away. But I'm not multiplying or dividing these two numbers. I'm adding them. I'm adding them by the rules of addition. They are different signs subtract. 12 minus 5 gives me 7. 12 is bigger than 5. Then 12 is negative. My solution is negative. Number 3. I'm not multiplying or dividing these two numbers. Essentially, that's a negative 16 and a negative 13. So I can write that as a negative 16 plus a negative 13. Now I know that these are the same sign. Since they're the same sign, I can combine them. 16 plus 13 is going to give me 29. Same sign combined, use the sign. Actually, I could have gone from this step directly to this step. As I know, I'm not multiplying or dividing these numbers. I'm either adding them or subtracting them. And actually, like I said, you're always adding based on the definition. And here's the rules. Negative 16, negative 13. Same sign combined, use the sign. My next problem, 4, 0, double negative. Notice there's no parentheses. Two negatives like this go to a plus 7. 0 plus 7 is 7. Number 5, 75 minus 85. I'm not multiplying or dividing the two numbers. I'm adding them. This is positive, this is negative. Therefore, I would subtract. But by the previous rules, I write a 75 plus a negative 85. Just as I said, positive 75, that represents a negative 85. Different sign subtract. 85 minus 75 is 10. 85 is bigger than 75. Negative 10. Number 6, 45. Double negative goes to a plus sign. 15. Same sign combined, use the sign. 45 plus 15 is going to give me 60. And we use the sign, which is a positive 60. Our next example, we want to find each difference. Let's look at number 1 here. And in these problems, since I have more than two numbers, I want to convert all the minus signs to plus sign, because remember, we're always using the addition rule as long as we're not multiplying or dividing. So I'm going to bring down the negative 4. This is a double negative. The double negative would go to a plus 8. The minus, that's a minus 9. That would convert to a plus, but make that a negative 9 and plus 10. So now I've changed everything to addition. Now I apply the addition rules. Like I said, if we're not multiplying or dividing, we're always applying the addition rules. Negative 4 plus 8, different sign subtract. 8 minus 4 is 4. 8's bigger, so it's a plus 4, positive 4, plus a negative 9, plus 10. Just bring everything else down. Bring it all down. 4 plus a negative 9. 9 minus 4, since they're different signs, I'll subtract, gives me 5. 9 is bigger than 4, therefore it's negative, so my solution for that little bit is a negative 5, plus 10. Bring that down, different sign, subtract again. 10 minus 5 is 5. 10 is bigger than 5, it's positive, so my solution is positive. Number 2, again, I want to change all my minus signs into positives or plus signs, so I bring everything down. 15 plus a negative 8. I have a double negative. That goes to a plus 12. Minus 4 goes to a plus negative 4. Again, if I'm not multiplying or dividing, I'm always using the rules of addition to find my solution. 15 plus a negative 8, different sign subtract. That gives me 7. 15 is bigger than 8. That means it's positive. Plus 12 plus a negative 4. 7 plus 12 is 19. Since they're the same sign, I combine them. Again, I have 19 plus a negative 4. And 19 plus a negative 4, different signs subtract. Use the sign of the larger. 19 minus 4 is 15. 19 is bigger than 4, therefore it is positive. On my last two examples, I want to use positive and negative integers to write two different subtraction number sentences for each difference. In other words, I want two numbers, positive or negative, that their solution here is a negative 12. I can have something that looks like this, a negative 24 minus a negative 12. That would give me a negative 24 plus 12, different sign subtract, and that gives me a solution of a negative 12. Now, I need to come up with a different one. As I said, I could come up with 2. Another one, I could have an easier version of just doing a negative 14 minus a negative 2. That would give me a negative 14 plus 2. A negative 14 plus 2, again, is a negative 12. So here are my 2 examples where I have a negative 12. Now I'm going to go to this problem. I have to convert this, though, as I have an absolute value of a negative 5. So I really want to change this to a situation where I have a box here minus a box here and equals absolute value of a negative 5 is 5. So I want 2 integers that when I add or subtract them, I'm going to end up with a absolute value of a negative 5, which essentially is 5. A quick and easy problem or expression to write to get 5 would just be 10 minus 5. 10 minus 5 is 5. Now I have to come up with one more because they asked for 2 different ones. And what I could do here is flip that around and go 5, a negative 5, minus a negative 10. Essentially, that's going to be a negative 5, and the double negative goes to a plus 10. And a negative 5 plus 10, different sign subtract, use the sign of the larger. That will give me my 5. So there are 2 examples to get the absolute value of a negative 5, which is 5, and 2 examples for the negative 12. Again, there are many, 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 many solutions for those 2 answers.